IME 450 Fixture Design Elevator Pitch by Aidan Montano and Jaime Arreola. For the problem identification, Cal Poly is creating box cutters to be manufactured, with both sides of the blades to be manufactured and assembled together for the finished product. Two separate operations are required to machine each side of the blade. Op number 1 can be done without a fixture and appropriate stock and a conventional vise. Op number 2 will require a special fixture to mount and clamp the previously machined op number 1. In order to reduce costs, a new fixture must be designed to be able to hold and alternate between both operation 1 machine sides of the blade handles. For the constraints and criteria, we must have a stock size of 0.7 by 5.875 by 7.5 aluminum. This must be attached to a Tombstone City tombstone in a Haas EC 400 horizontal mill, must be able to be indicated to CNC machine axes, must be able to produce one finished part per loading cycle, must be able to part off qualified datums machined in CNC operation number 1. Load and unload time must be under 1 minute. The clamping forces must withstand the tooling forces with minimum safety factor of 3.0 and use Mighty Bite fixtures supplies provided on the shop floor. When it came to tackling the problem of creating a fixture, the correct datums need to be identified to be located and controlled when designing the fixture. In the drawing above, we see datums along the long flat side of the blade, datum B, as well as the bottom flat part, datum A. The last datum C is the butt end of the blade handle. Starting out with some concept sketches, the design was primarily guided by datums and elements of fixture design, those elements being locating elements, structure, brackets, clamps, screws, or jaws. Opting for a simplified design, the max total area of the fixture plate was used in the design. At the very top of the fixture are both an indicating band and locating board, allowing for the accurate alignment of the fixture onto the CNC machine mill, as well as channels on either side of the fixture for T-slot clamps. For the blade handle locating elements, we will have a Mighty Bite parallel rail attached alongside Mighty Bite hexagonal clamps. This allows datum along the flat side of the blade handles to be located. It should be noted that the clamps should always be located against locating elements. Next are the locating pins on each side, allowing either side of the blade handle end to be butt up and located against. Lastly, the machine cavity in the middle is where the blade will sit, which is machined to flatness. This allows the location of the last datum located on the bottom part. Here's a drawing of the fully assembled assembly of all the locating elements and clamping devices. This is valid for both sides of the blade handle seen here. Alongside this is an exploded assembly with the correct components labeled in the bill of materials. Lastly are a few standard parts necessary for the operation. Cutting forces of the tool and consequently the clamping force required for these cutting forces need to be found. When calculating the cutting force, we used Excel and created a precise, easily maneuverable tool to find the tangential cutting force for efficiency and concluded that the tangential cutting force was 35.64 pounds. Since we required a safety factor of 3 or more, knowing static friction coefficient is 0.61 and the required clamping force is 175.28 pounds, we conclude that the factor of safety is well above 3. Since two 800-pound clamps gives us 1,600 pounds force available, this will give us a factor of safety over 9. FE analysis was done on the direct portions of the clamp that make contact with the part. This is done to side 2 as there is a very thin wall that is in contact with these clamps. Max displacement is found to be 1.13 times 10 to the negative 4 inches, which is small enough not to affect the part. For the stress results, the maximum von Mises stress is about 22 megapascals, and since the 6061 T6 aluminum yield is about 275 megapascals, the fixture remains well below yield and maintains positional accuracy. Listed above are the required tooling needed to fully machine the fixture, along with specific actions and total machining time. Once the manufacturing plan was complete, the tool paths were generated in HSM Works. In addition, in SolidWorks for CNC programs, and the plate was then sent off to be machined. Total time for the fixture machining was about 22 to 23 minutes, with only slight hiccups after the machining was finished, dealing with only the CNC code, which did not ruin the project. Once our fixture plate was completed, the geometry and CNC program of the blade handles need to be associated with our fixture geometry. Images of this can be seen above. Once the blade handle was associated, ensuring the CNC tool paths did not collide with the fixture. Slot nuts indicated parallel to the CNC mill with the indicating band, and work home location set up with the machine bore. Here are a few videos of the CNC machining operations for Op 2 once the blade handle was clamped to the fixture. The overall machining of Op number 2 was a success. The single fixture supports both blade variants, meets the dimensional constraints, safety factor requirements, is compatible with the Haas EC 400, and allows for fast loading and unloading of the system. With fixture design similar to cutting force, we also created an efficient method for calculating the fixture cost in Excel. With Excel, we were able to create the breakdown into 5 separate categories: engineering costs, material, standard parts, assembly, and machining. The fixture cost being roughly $1,112.56. Our fixture is superior because it supports both parts in one fixture. The safety factor exceeds the requirements, low manufacturing costs, contains simple machining operations, and a strong locating. Improvements to be made are making the fixture smaller to reduce material costs, as well as making bigger T-nut slots.